the neurons from the matrix zone migrate through the intermediate zone to the cortical area, forming what you refer to as the cortical plate. And then we have those neural plates are still able to undergo mitosis, so they multiply and they reorganize to form the cortex, cerebral cortex. What remains in the interior are the axons of those particular neurons and also axons from the ascending fibers. And that's what we refer to as the white matter. So the white matter is on the inside, the gray matter is on the outside. And we say the main purpose of this is to increase the number of neurons without increasing the size of the brain. And this more so in the neocortex, the new brain which is just developed because of our complexity in what we do. So we had looked at general functions as integration. So I'd like us to today go into that histology. And in looking at that histology, we talked about the histology of the cortex being very thin, like in the case of the occipital lobe, area 17, about 1.5 millimeters, up to 4.5 millimeters in the motor cortex. So why is there that difference in the motor cortex? Now, in terms of function, a gentleman by the name of Brodmann did some what you will call mapping, which is more or less so accurate. In terms of function, he looked at if you pricked some parts of the brain, more so during the war, some people's skulls were blown off. So whenever a part of the brain was pricked, that person will behave in a specific way. There'll be a movement or the recall of some object, recall of some memory, and therefore he assigned numbers to the various gyri of the brain and specific parts of those gyri of the brain. These numbers is what you're calling Brodmann mapping. And in that Brodmann mapping, broadly you can see a lot of numbers here. And of importance is this central sulcus, which we talked about yesterday or the day before. So the central sulcus which one here divide the brain into this part here, which is the sensory part, and this part which is motor. Of these parts, the sensory part is a primary sensory in the postcentral gyrus. So the postcentral gyrus is primary sensory. The precentral gyrus, which is number 4, is primary motor area. Now, this primary motor area and the sensory area represent the various parts of the body. So we have what is called homunculus. In that homunculus, the body is mapped. The neurons represent coming from the specific areas of the body are located in the specific areas of either sensory or motor parts of the cortex. That's what you call the homunculus. Now, the representation is not generally equal to the area of the body. The representation is equal to the activity of that area of the body. For example, our trunk, you might not have a lot of activity in the trunk as compared to our thumb. So the thumb has a bigger representation compared to some parts of the body. Those areas which have more neurons regulating fine movement, for example, those ones will have a bigger representation in terms of the area in the cerebral cortex. So these are the structures we are going to refer to. We have said this part here, which is mainly representing the parietal lobe. That one there is the sensory areas, primary sensory areas. This part, which is representing part of the frontal lobe, is mainly motor areas. So this primary motor, and these other ones are premotor areas. Premotor, before motor. These other parts are post-central gyrus, which is primary, but these ones can act as association areas. So we divide generally the brain areas into sensory areas and also the sensory areas, which is primary sensory area. I've said 1, 2, 3 primary sensory area, and sensory association areas. Sensory association areas. So the occipital lobe is primary visual area. So this is where our visual axons from the retina project into this area 17. Area 18 and 19 are visual association area. So this is where there is that interpretation. In the association areas, there's interpretation of what comes to the primary areas. The olfactory cortex and piriform lobe, this is what you are calling the piriform lobe here. The olfactory cortex mainly is for gustatory, that is taste sensation. So we have primary taste sensation areas, area 43, and then primary auditory areas, also the hearing areas. So we have auditory, primary, and auditory association. What you hear goes to the primary, and then to be able to interpret that, the information must flow from the primary to association area so that you can relate that sound to a particular person or a particular activity, a particular musical note. That is what happens in the auditory areas. So we have other areas, these are sensory areas. Now, we have also motor areas. We have said the primary motor area, which is area 4, then we have premotor areas. Area 4 is primary motor. So all our motor activity emanates from this area in terms of control of those motor activity, emanate from this area to specific parts of the body. That's what you're calling topographic mapping. And then the premotor area, which is area 6, this is now where that motor activity has sort of been learned. You learn a motor activity, after you have learned it, you don't even assume it. It's automatically, it's automatic. When you walk, it is something that's automatic, but initially you have to learn. The initiation of that movement comes from that area 4. Specifically, there are areas which are specific for certain motor activities, like the Broca area, area 44, 45 is area 44 here. This one here is specifically for speech, in terms of speech. So it regulates our muscles that are important in generation of speech. In generation of speech, the actual talking. The frontal eye field, which is number 8, regulates our eye movements, muscles that go to our eye movements. Then we have association areas. Now, association areas, we have prefrontal cortex, we're going to look at that. Area 9 to 12, these are very important areas. This is an area where you have mainly decision making. All these prefrontal area from number 9, 10 to 12, all these areas are very important. And then the area for understanding things is a higher brain area. This is now dependent on higher brain functions is dependent on the specific action that is supposed to be done. Then the Wernicke's area, this is a speech area, but it is motor speech area, association area, that when you hear something, the other one was being able to speak, to control muscles. But in this speak area, in the Wernicke area, this is now the linguistic interpretation of what you hear. Linguistic interpretation of what you hear. We also have other areas with visceral association areas. These ones regulate our visceral functions. So you can see that the entire cerebral cortex is very important in regulating our body activities. And these body activities gets the information from the various parts of the body. And all that information comes to this particular part, which is the sensory area, and then that is now distributed to the other parts. Now, our prefrontal cortex, so it's area 9 up to area 12, is very important. And this is an area where you have orchestration of thoughts and actions in accordance with the internal goals. This is the keyword: association, orchestration of thoughts. You think about something, and actions. You decide to do something in accordance with the goals, internal goals. What is your internal goal, for example? Your internal goal could be like what we discussed before. You want to micturate. So from the content micturation center, you have had already feedback from the bladder. The bladder is full. You want to go and micturate. That decision to go and micturate, to go and pass urine, that decision comes from me. You think about it, you act. That action now comes from the prefrontal areas, and we have descending fibers now through the spinal cord to the areas responsible for micturition. Parasympathetic activity from S2, S3, S4, and relaxation of the internal sphincter, in the external sphincter. So this is important for that particular function. So it means that our prefrontal cortex is very important as an executive function of the brain. What do the executives do? If you're an executive of a company, what do you do? So the brain, our body is like a company, and we have to make sure we decide on certain things: the intellect, the learning, expression of personality, abstract ideas, reasoning. You have to reason. Planning. You plan. You reason something before you're able you reason, you keep on, you fail, you keep on repeating. Why? That decision that you have to repeat, continue repeating something is coming from the prefrontal cortex. Our conscience. They say conscience is the biggest accuser. We don't that conscience
Oh, shit.